All right, number 4. A 75-kilogram bobsled is pushed along a horizontal surface by 2 athletes. After the bobsled is pushed a distance of 4.5 meters starting from rest, its speed is 6 meters per second. Find the magnitude of the net force on the bobsled. Again, some things I know. Here is mass. This looks like a distance. Starting from rest, so that's going to be an initial velocity. This would be a final velocity. And then yeah, there's no angle here, right? Yeah, so it'd just be cosine of 0. Yeah, fine. All right, so that'd be easy enough. Again, we're using the work energy theorem here. This is net work is equal to change in kinetic energy. If we have no potential energy here, we don't have to worry about potential energy. So that means that this is simply, my handwriting's very good, whatever the final kinetic energy is minus the initial kinetic energy, which is to say, it's 1/2 mv final squared minus 1/2 mv initial squared. If I know, well, that the net work being done is also equal to the net force acting on, I guess it's a bobsled here. I guess I don't have to actually write cosine theta because it's going to be cosine 0 degrees. It's just going to be 1. It's not going to actually change the value at all. But what I can do here is I can substitute in for net work these terms up here. I can combine these terms because the net force, let's see. So if I solve for net force, which is what I'm supposed to do here, net force, again, you can actually keep these things the way they are, or you can factor out the 1/2 m. Makes things a little bit simpler in terms of plugging into your calculator, right? See how the 1/2 m is the same on both of these? So I can actually factor 1/2 m out of that. So in a parentheses, it'd be final velocity squared minus initial velocity squared. Makes things just a little bit easier. But as long as you do your calculator work correctly, it won't actually change your final value. If you want to keep it in the extended version, that's also a-okay. And again, there would be a cosine theta right here. But again, cosine of 0 degrees is 1, so I'm just going to go ahead and leave that out there. So when I'm getting ready to actually plug and chug, I got 75 kgs. I have, do that a little bit. And I have my 6 meters per second squared minus my 0 meters per second squared, right? Because that initial velocity was 0. Then I'm going to divide that by 2, right? Because it's 1/2. 2 times, what was my distance? 4.5 meters. And that's going to come out to be, with 2 sig figs, 300 newtons. Again, 2 significant figures.